And then in our lives.
What is this matters? It also be matters.
So you want to
It's either here, it really has got to be either here or here.
I asked Peter about this loop satellite loop for the week because they can see the trough, even this the water being
Only was snap for, honestly,
Which should be cool.
that'd be fun.
Okay.
Yeah, no, that isn't it.
Okay. I mean, it sucks.
It's such really similar people drive places, but
I've got this other, it's kind of like a basketball practice.
I had to school a couple times. So nice. You gotta hit that sweet spot though, where it's enough to get you out of school, but not enough that you lose power. When you hit that sweet spot, it's usually great.
My favorite thing about studying and stuff is so then
They're worried it was a snow, you just gotta go on your
Yeah, I know. That's yeah.
that's like,
Well, you live this thing.
it's like I.
Just the water vapor, I think, yeah. I was thinking getting a loop of a week to get us to the beginning.
Okay, welcome to our weather discussion. I reminded myself, I'll have to say, I reminded myself this is the first weather discussion since the glorious World Championship won in Los Angeles on Sunday. In case you don't know what I'm talking about, the Red Sox won the World Championship again. And that was very pleasing to me. Although it would have been a better series if our Milwaukee Brewers had played. And it would have been more difficult for me to know which side to come down on. But so anyway. And it's the last weather watch before you vote. So make sure you do that. I don't care who you vote for, but you got to vote. That's what people have died to make sure we can do. So make sure you do it. Okay, here's our water vapor movie for the last week. It has been an interesting week. So first, early in the week, we had this cyclone that came by us. This was on the weekend, wasn't it?
Yeah.
Saturday, Sunday. We had kind of a rainy, on and off rainy weekend.
And it was rainier than we suspected, as I suspected.
Yeah, that's right.
Saturday.
That's right. Saturday was a lot rainier than I thought so too. Then there's Oscar out in the Atlantic. And the storm that came by us turned into a fairly major event up in maritime Canada and was followed by another one, which will become part of the focus for today. And that is, you can see it kind of emanating from a southwesterly plume over the central United States. And the cyclone itself took shape over Ontario. Oh, no, I'm sorry, that's a prior one. This is the one that came around Halloween. And it rained very heavily over the Ohio River Valley much of that day. And then it's continued to stream forward, and now it's raining over New England. So I'm going to show you 2 days of accumulated precipitation near the end of this movie that will suggest that we're really quite remarkable heavy precipitation amounts. And the other thing that's interesting about this storm, this last one, not any of the ones that prior part of the sequence, is it was such a weak sea level pressure minimum, hovering around 1,000 millibars over a period of 2 or 3 days, during which it gave all this precipitation. So there's a real big lesson in there, which is every one of these storms has a potential impact, and some of them have impacts that far exceed the profile that they pose in their sea level pressure minimum. So if you're a professional forecaster or a risk analysis person, do not neglect the potential impact of what look like weak storms.
Right. I was going to also add that the rain that, the accumulated precipitation, that rainfall that was occurring with this significant rainfall was wet in Detroit yesterday. And just less than a mile above the ground, it was snowing like crazy.
I said that today in class, the 100 class. I told them it was snowing about 2,700 feet, you said?
Meters.
Meters, okay,
Yeah.
so about a mile above, a little bit about a mile above. So the snow level is coming down, and then of course it is November 2nd, so
Right.
yeah, that's pretty neat. And the picture you showed was fantastic of the
I'll
snow.
share that at some later time. You want to see it? I'll show it to you. It's a photography fail, but anyway.
Yeah. Did you have anything you wanted to say?
It was just just the deep trough that develops. You can see these dry areas on the water vapor, the warmer colors, and those just indicate a very low dynamical tropopause, low tropopause itself. And you can see these intrusions that are becoming more frequent as we head later into the season. I think you're going to be showing an example of one of these deep troughs.
Yeah, fairly weak one, as it turns out. But nonetheless, an example. And when we go one more animation, here's an example of right up here on the border of Manitoba and Saskatchewan, there's a really nice small-scale vortex in the upper troposphere that shows up here. It never really turns into much of a cyclone, but then there's a string of different disturbances in this broad upper trough. Look at that; they keep on buckling in the water vapor. That's kind of interesting. As that storm came through us over the weekend. But we go back to the beginning. I want to show that one thing. No, we're almost there now. So right there, look at that beautiful little vortex. Probably only in the upper troposphere. Then a linear feature comes in, and this is kind of what's related to our current development that's about to occur on the East Coast, but not that one, but something like it. And then watch around the periphery of the deep trough. When this cyclone comes by, it's like an Alberta Clipper, actually. A month or so from now, we get 4 inches of snow out of that. There's a whole bunch of little swirlies. There's one. There's going to be a couple more that develop. There's another one. It's really nice. This might not be the best way to see it. Maybe the gray scale is even better, but sometimes it isn't. So anyway, it's the active time of year. Lots of interesting things are starting to happen.
Right. But the key thing about these imagery, the imagery that's being shown, these warmer colors indicate areas that are dry and often of sort of historic subsidence that's occurred in them over the lifetime leading up to that time in the image. And the cooler colors and the greener ones are just indicating significant water vapor, particularly in the upper and middle troposphere.
Yeah, and those yellow regions here are regions usually of fairly large values of upper tropospheric vorticity as well. So you can sometimes, especially in the vicinity of a storm like this, that's a big vorticity feature. And you can see that probably in a companion analysis. And that can be useful if that's all you have for some reason. You would know that you have an upper vortex here, and it's immediately down shear of it that the cyclone is getting spun up, and that's perfectly in conformity with basic dynamics about cyclogenesis, cyclic development theory. Okay, so let's take a look at maybe our more proximate in time satellite movie, and we can do the visible, I think, at this time. Yeah, so here we're going to see the remnants of what has been a really weak sea level pressure minimum trudging its way from about the eastern part of Texas and then up along the baroclinic zone, which is clearly evident in the clouds. And you'll see when we look at some other observations that that's the case. But this has been historically a very strongly chronogenetic baroclinic zone over the week. In fact, that's what's been responsible for the heavy rains that I'll show you in just a minute. But not much of a cyclone. In fact, the flow is so strongly stretched and deformative in that way, it's very hard to get a sea level pressure minimum to spin up. But suddenly, near the middle or late part of this weekend, over New England, when it seems as though all is lost, boom, the bottom drops out, the thing goes down into the low 970s in almost no time. So really interesting.
Right. John, I don't want to jump ahead because you may be about to say this, but the precipitation with this, I haven't looked carefully at the intensity, but it's the amounts that you're impressed with.
Yeah, I'm impressed with the amounts, yeah.
And I'm wondering, this is one of these cases, we talked about this number of times in past years and past weather watches. You can see it over the Atlantic, this is broad anticyclone that extends off the map, off the side of the eastern side of the map, all the way across to the northern Caribbean, central Caribbean, and then it kind of the return flow, the northward flow is all the east coast of the United States. And I'm wondering, it seems very often when you get these heavy precipitation events, accumulations, it's a slow-moving front on the western edge of a subtropical high.
Very true.
And just the feedback between the precipitation, the high itself, and just the location of where that high is located to help feed the moisture transport in just the right location.
That's a really good insight. And to finish the one link you mentioned about the feedback between the precipitation along the front and the anticyclone to its east, this is, of course, producing or destroying upper PV, so reducing the PV in the upper troposphere, and then it gets kind of axisymmetrized into this disturbance. Peter Knipritz and I were looking at something like that many years ago, 2007. It was a really nice paper. It was mostly his idea, of course, but he was looking at how, I think we were looking at how plumes develop over in North Africa for a heavy event in Morocco. The predecessor event is this giant latent heat release event along the East Coast, which builds up the ridge, which on the eastern side of the ridge produces the southward advection of high PV into a narrow sort of positively tilted plume. And that brought some really major events, precipitation events to Morocco, as it turns out. More than a season's precipitation in one day or something out of one of those events. So there's a lot of connections, and you're right, I think that's something quite interesting about this event. Earlier this week, not recorded by a observing network at the ground, but shown very obviously in the forecast panels for both Tuesday and Thursday. Big anticyclone off the west coast. We may still see evidence of that when we go to the west coast. And in between that and a sort of positively tilted skinny trough, a persistent band of modest to sometimes heavy precipitation in the forecast. So it was probably very similar to this one, and probably reinforced the ridge over the west coast, which is still really there. It's quite a nice day the other day. So there's a lot of really interesting things that start to happen here. You can see them all. You can see large clues about them when you look at the satellite. So let's go to the radar next, if we could, Pete. So we'll follow what's going on the East Coast here first, and then we'll go to the West Coast. But here's the radar currently. And so the precipitation over New England on the northern edge of what has been a fairly impressive and persistent band of moderate to heavy precipitation is kind of looking a little bit scattered over Maine and the Maritimes, and then further south to like Long Island. It's not so scattered across southern parts of the Carolinas, straight through central Georgia, and then off the panhandle of Florida. That looks a little bit more like what happened yesterday, much farther to the west, and was tied to this broad structure. And in fact, there were no tornado reports, but there were a lot of wind reports, 26 or so wind reports down over the Mississippi-Alabama Delta. So it was a fairly severe day, but not quite past the level that people down there really get nervous about. They can deal with some winds. They didn't have any hail, they didn't have any tornadoes, but period of heavy rain. And if you noticed the reflectivity yesterday, early in the day, really intense line of convection, and then later in the day it kind of broke itself up a little bit. Looked more like what's still going on here over parts of Florida. So that was an interesting event. A very weak disturbance over central Missouri. The eastern portion of it is precipitating. The whole circulation, though, is obviously counterclockwise. When you look at the satellite movie, especially the infrared, is easier to see it. You can really see these are low clouds, but nonetheless, one can see an obvious center of rotation just now south of Kansas City. And then the precipitation over Montana, parts of eastern Washington, and some torch that's been lit in Seattle. That's all part of a landfalling system that's beginning to decay. But there's a series of systems upstream of that one. And one of them is already in a robust development stage, but there's a series coming in the next week that will bear watching in the Pacific Northwest. It's going to be an interesting week. Offshore, it won't be so much on, but it'll be offshore. So that'll be kind of an interesting thing.
So radar. So
yeah,
the weather system that's located over Missouri and Arkansas. That one you said it was weak, but it's maybe more weak at the surface, right?
Yes, I meant to say that. Yeah, weak at the surface. It's a pretty obvious upper disturbance, and in fact, that's reflected in the clouds that I saw in the infrared that we looked at earlier in my other class. So. Yeah, that's correct. It's not particularly robust surface cyclone, but there's a pretty potent circulation. What I wanted to show you next was staying, paying some attention to this feature that's now moving off the coast. Let's take a look at these precipitation analysis from the Hydrological Prediction Center. So this is yesterday's one-day observed precipitation valid yesterday morning. And so here is, I guess, Halloween Day and part of that night. So it was raining on ghouls and goblins in southern Indiana and parts of southern Illinois all the way down to, unfortunately, the state boundaries disappear, but I'm saying that's probably about the Dallas area. This is maybe more like Houston. And so heavy precipitation, look at the scale. You're into the 3 to 4 inch range in this red, and then everything in the darker green is between 1 and 1.5. So this is a substantial region of really heavy precipitation. Though, as Michael pointed out, never particularly intense at a moment, just persistent. So
just to continue with your discussion of ghouls and goblins, you're basically saying no one had a ghost of a chance of staying dry.
No, they didn't. They didn't. Although my daughter lives in Bloomington, and they hosted a couple of little kids on a rainy night. They came to the door, and she said they were real gamers going out on a rainy night because it was raining and not particularly cold. It was quite warm, but it was a rainy night, so too bad for them. But there'll be other Halloweens. And it's obvious that there's a linear aspect to this precipitation accumulated that day, and we're going to see that is tied to a very obvious baroclinic zone that was exactly aligned along this Gulf of St. Lawrence all the way down to about central Texas. And then a development to its south began to emerge, and we'll see if we go to view today's analysis. This will be yesterday's precipitation through 12Z this morning, and you can see I'm probably going to fill in a little bit more. Not sure what happened there. I saw earlier. There you go. This is a more substantial amount of precipitation formed on day 2 as the cyclone, though weak, finally started to get itself together over the southern Gulf states. The baroclinic zone, as you can see, had stayed just about in the same location, and it was, not really having much to do at this early stage with that cyclone, but continued heavy precipitation in parts of Illinois and Indiana. So some of those places, I don't think Bloomington was among them. Indianapolis, though, maybe had 5 inches of rain over the last couple of days. That's a lot of rain for a fairly non-convective event. So a really persistent rainy day. Looks like our Tuesday is going to look like that, election day. So plan accordingly. So that's kind of an interesting event. Now, the reason that I wanted to show you this, I don't know if there's an easy way to go and look at, maybe Alicia Bentley's maps is the place we can go, where you can look at historical sea level pressure forecasts.
And say for future versions of this, you can get a higher resolution version of this picture.
Oh, is that right?
That's what I'm not going to do now.
Okay.
It also overlays states. If you scroll down a little bit, you can click on the button above state, and then
Oh, okay, that's nice. Yeah, that's nice. That's good. Okay, so those are good things. I found this kind of quickly this morning, so I didn't even know it existed till then. So, yeah, let's try Alicia Bentley's maps. And then we'll go to over here and we'll take a look at North America. And then scroll down. Let's go backwards in time. I think you can do that with your arrow keys. Yeah, perfect. So let's keep going. Let's go a little further south. Right about here is good time, right at this time. So now we're going to find out what time it is. I know this is kind of not so easy to manage all that. This is now
0Z on the 31st.
Okay, so I initialized 060 on the 31st. So, okay, yeah, so it's midnight-ish, just before Halloween. And so here's the sea level pressure minimum that's not even analyzed as such. Here's the prior one that had gone through us earlier in the day, and then the baroclinic zone you can see in the thickness field. And then on top of it, the 250 millibar wind speed maximum. And there's Oscar, and it's part of its outflow jet, but also it was escorted to the mid-latitudes by a tropical bubble. And there's the boundary on it. So let's watch what happens to that sea level pressure minimum. So let's go. I think these are every 6 hours. Yeah, every 6 hours ahead. So still doesn't have its own designation. It would be 1,012. Still 1,012, I believe. Starts to look like finally a sea level pressure minimum at sort of late afternoon, early evening on Halloween. And that's still, pressure is at 16,000, 12,008. So it's about 1,008. 1,012, 8,4, 1,004, a little bit of deepening. Wow, going to town on that. Then it's down to 1,004, but the area is expanded, so more intensification. 1,004, yeah.
Yeah, the other nice thing is if we step through this, you can also notice how the jet begins to develop almost sort of southwestward.
Oh, yeah, right here.
Yeah, if you go back to the beginning, so if you step, as Pete steps forward, look over Missouri, Arkansas, that area, near the cyclone center, you're sort of seeing the jet maxima, and that might be some sort of extratropical cyclonic outflow from that.
Yeah, and in addition, there's a lot of frontogenesis going on here, and so there's diabatic outflow steepening the tropopause here also, so I thought that's what you meant, okay. And then we're at 1,004, and now we're only 18 hours prior, still 1,004. Look at how it's just not deepening. We can go, keep going deep. Then finally we get down to 1,000. That's about all it's going to do is 1,000 again, 1,004, and now it's weakening. And this is now at the current time this morning. So over a period of those 2 days, this storm hardly deepens at all. And that's really interesting to me. Look at how the jet become kind of right on top of the baroclinic zones, gradually slid this way. And that's frontogenetically active, and that's really the major producer of the heavy precipitation, heavy amounts of precipitation. And so I'm going to leave it there because Michael's probably going to pick this up in the forecast. But this is a really interesting non-developmental situation that will suddenly be transformed. And we want to pay attention a little bit to how it gets transformed. So what I will do is look at the current observations at upper levels, because in the thickness field, one gets the impression that there's an upper vortex generating right about in that location over Louisiana and Mississippi. So we want to see maybe where that came from. So here is the current, almost current, 7 a.m. this morning analysis at 500 millibars. We're going to look at predecessor maps in the northwesterly flow upstream. I told you that we would do this here. And we're gonna see that there's a very weak, but I think discernible upper level frontal development here that eventually gets itself, that baroclinic zone gets itself embedded in the base of this trough. And we have 70, 80 knots down near New Orleans and so on, pretty strong winds, 85 knots near Nashville and so on. So pretty strong wind speed maxima over the eastern United States, and an elongated one with not much of an entrance region and not much of an exit region. Strong baroclinic zone underlying it. But decent curvature. Limited, though, in its areal extent because there's no immediate downstream ridginess. So all of the cyclonic curvature and the agiostrophy that's generated by it is going to be quite contained in a local spot. There'll be a lot of agiostropic divergence here over northern Alabama, Georgia, and western Tennessee. And that's about where the cyclone center was at that last time.
And John, that's also, this structure, I haven't looked at the maps just before this, but I imagine you have a flow that's pretty much that straight. You're not going to expect much support, for lack of a better term, for surface development.
That's right.
In a flow like that.
That's right. That's exactly right. And if you look carefully at this map, there's a leading curvature feature. Then there's a secondary one over the Kansas-Oklahoma border. Here's where the winds get to 90 knots and the baroclinicity is stronger. It's this feature here that's, I think, the upper frontal feature. And they're going to get phased. It's going to take them a while to do so. When they finally do, it's kind of up here over New England and things go crazy. So it's really a weak, not particularly strong thermal perturbation associated with this wave and a very strong tropopause fold type structure with this one. They're going to get their act together. I hope to show a little bit of that in this 5D. So keep in mind it's 12Z on 2 November that we probably have a close proximity, but not a superposition of these two features.
Right, just to anticipate the next, the discussion that's going to have for the forecast. Also, just notice this broad, kind of northwesterly flow over the Rocky Mountains. So there's not much of cross flow at this point, but watch how that changes. We'll see how that changes. Just keep that in mind.
And then the last thing I'll point out is, I won't point this out because that's in the past. This is in the future. Strong baroclinicity associated with a really strong 500 millimile flow over the, so at the latitude of northern British Columbia. So that's a strong horizontal temperature contrast. Had the map were the map to extend further to the west, you'd see even more of that. That's a really intense jet, and maybe we'll look at the 300 millibar jet 0 hour forecast on the 104 grid just to get a picture of that. So let's, in fact, why don't we do that? Let's go to the 0 hour forecast at 300 millibar. We could. Yeah, because the shading can make it easier to see from a distance. Yeah, okay, great, thank you. So here's the strong jet on the East Coast. Here's a little jetlet in the northwesterly flow, and at the base of that, right over the Kansas-Oklahoma border, that's where you're getting your sort of focus of, I presume, upper frontogenesis at 12Z. We'll see if that's right. And then we just saw the western edge of this, or the eastern edge of this 160 knot jet. So this is a really almost zonal 160 knot jet at about, I don't know what the latitude is here, probably about 60 degrees north or something, 55 degrees north. And it's got a pretty strong exit region with a really strong anticyclonic curvature feature in the exit region. So lots of ascent going on just to the south of Kodiak Island or over the southern half of the Aleutians associated with this structure. And there's more of it upstream. So it's really gotten revved up over the last couple of days in the eastern Pacific. So bearing that in mind, let's take a look at the satellite movie over the eastern Pacific.
It's loading up. It's also unlikely you're going to keep a jet that long, that zonal.
Absolutely right. Yeah, Jules Chani was among the first to notice that. You just can't because the baroclinic instability prohibits it. And so that's not going to last long. It starts to break up, and that's when the weather gets really exciting. But look at this storm. A little bit displaced from, I think, what we would have expected at 12Z, but not, that's because it's deeply occluded. I guess the peak of the ascent is probably still here, and this is a lot of the rotation in the upper vortex. But that's a beautiful looking storm. Finally, it's taking forever for the Pacific, the Northeast Pacific, to have a really characteristic looking disturbance over the Aleutians. But this is a deep storm. It's probably down in the low 970s, seas are 30 to 40 feet probably, and not particularly cold behind it. That's interesting. Maybe well behind it, it's kind of colder. And then a widespread cold front and then cloud head in the warm frontal region of the storm. And it's deeply occluded. I expect that's kind of the triple point, right about there, cold front, warm front, and then the occlusion goes back to the circulation center or close to it. And then you can see the storm that's made landfall in the Pacific Northwest is getting itself shredded by the Canadian and northern United States Rocky Mountains. So it's not going to have much more structural integrity. But there's a whole lot of things going on in the northwesterly flow here that you can see on the periphery that are quite important interest for us, both in the continental U.S. and maybe even over, as Mike was pointing out, maybe even over our own region of the continental United States. So let's, if we could,
Just one note about the goes west.
yeah,
GOES 17 has started migrating over to the goes west position. We should start getting imagery from it around mid-November.
oh, 2 weeks then, maybe
So we'll
2
start
weeks from now.
getting loops like this, but or
Oh,
like
nice.
the GOES 16 stuff, but over the Pacific.
That'll be great. Well, I did want to show one thing, Pete, and that is the update on the hemispheric cold pool for a combined September and October. I put that image down here somewhere. There it is. So this is it's actually to 2016 or 17. Sorry, it's 1948 to 2017 average. It's almost a 70-year average. And I fooled around a little bit today and did the kind of more normal thing, which is use your real climatological averages of 30 years and you move them every 10. It doesn't change this very much. It does a little bit, but it doesn't change it very much. This is the time series of the hemispheric cold pool -5 air at 850 aerial extent for the current year, right up to October 31st. And it's interesting, when you combine the 2 months, we're the 11th warmest, and warmest meaning, integrated departure below the average. If that's large, you're a warm year. We're the 11th warmest year out of the 71 in the record. So that's 15th percentile or something. And the month of September was only the 20th warmest because it had this warm period at the end. October was the 6th warmest of all time. So it's really been an interesting year so far. And of course, I think our October locally has been anything but warm. Nobody would remember it as warm. You might not remember it as particularly cold, but I think the temperature is about 0.1 degree or 0.2 degrees below normal for the month. So it was just at or slightly below normal regionally, but over the hemisphere it was the 6th warmest October we've seen since 1948. So that's kind of interesting. I'll keep you posted on this. So this is something that attracts my attention. Perhaps now it's a distraction instead of something that's useful, but I can't help it. I'm still interested in it. So, okay, that was the other thing I want to show. And then let's take a look at this 5D if we could. And the idea here is going to be, I took an old model run because I wanted to see what the precursor conditions were. This is from 12Z, initialized 12Z Wednesday, GFS. And I think they go every 6 hours, did it be? Or is it every 3? I think it's every 3. Yeah, it's every 3. And I think it's going to go out then to something like 5 days. So we'll be well past the current time. The current time will in fact be right about in the middle. So this is the 500 millibar potential temperature. And one can see a couple of interesting features right at the beginning, midday on Wednesday or early morning Wednesday. Strong baroclinic zone draped over us at 500 millibars. That means its companion structure would be farther to the south. And it was a deep structure. This was a deep frontal structure, frontogenetically active precipitation band that we saw in the accumulated precipitation from the hydrological center was right about there, and it's tied to this feature. And then that baroclinic zone is tied to an occluded storm way up over central Hudson Bay. So that's the initial condition. Then there'll be northwesterly flow. So let's just march ahead. Can we put the vorticity on there, which is QZ? And I put values of the 500 millibar vorticity at 0.4 times F and higher at 0.4 increments. So these are the vorticity maxima. Maybe that's not enough. Then let's go down to, change it to 8, start at 16. Just get rid of some of the clutter, see if that helps. Yeah, it helps a little bit. So you can see the main vorticity features a little bit more clearly. And there's one right off of the British Columbia coast. So let's march forward at a steady pace, because we're going to be watching what happens in the northwesterly flow. Today's Friday. This is the feature of interest. This is kind of a linear vortex strip. We saw this in class yesterday in the 500 millibar forecast. Let's watch what happens with a couple more iterations, stopping right about 18 feet, or right 0 feet, perfect, 0 feet. And so even though I've artificially truncated the contour interval, you get a pretty nice vortex strip over western South Dakota, North Dakota, and it's connected to a pretty decent baroclinic zone, as you can see, right in that location. I have a cross section ready in the theta, and right there. And so that's going to cut right through that baroclinic zone, somewhat perpendicular to, almost perfectly perpendicular to it. And I did it a little bit to the north of the maximum vortex head. And then let's take a look at that structure in the vertical. So that's a pretty nice baroclinic zone. It certainly never reaches the ground, so that's an upper front, right? And let's take a look at the potential vorticity, which is right there. That's ready to go on the same cross section. Here's the PV, every one PV unit. And so I like theta on top of the 2 P things. And so the 1 PVU value here, first of all, on the cold side, you're on, you got a really low tropopause. You can tell that even just from theta. On the warm side, a really high tropopause, and that's reflected in the 1 contour doing that bit of a dance. And there's a protrusion of higher PV all the way to 500 millibars. Notice that it intersects about the 500 millibar surface, right at the point where you get that vortex strip. So the question is, was this air coming down these sloping isotropes? And we can't do an exhaustive investigation of that, but if you slide up and get omega, I've got, or W, I've just got downward vertical motions there. And there is a big pocket of downward vertical motion right at the spot where there's a protrusion. There are other places where the air is sinking as well, but that's one that's rather probably directly involved in the subsidence of this high PV along those isotropes. And so that's where that upper vortex comes from in this, at this particular time. So if we go back to the top view and then get rid of all those cross sections, I made other new variables with the same values. You're still gonna have to slide down to get those feet. Yeah, they're at the bottom, but don't put them on yet. We're going to march forward some more in time and watch this structure. Yeah, if I go all the way to 12, or which time I go, we'll see when I get there. I think it's probably this time. Let's see, put one of those cross sections on the theta. No, it must be back. Oh, that's right. Okay, that's probably right. Maybe one more time forward. Yeah, I think it was this one. Okay, so it's this time where that vortex strip and the head of maximum vorticity and baroclinicity is now on the Kansas-Oklahoma border. Almost at the time, I didn't pick the right time. Should have been 12 Z, because that's what we saw in the observations. But we'll stick with this. So let's see what the thermal structure looks like at this time. And it's still a fairly intense upper front. It definitely is an upper front. It has no feet in the troposphere. It probably doesn't even go below about 550 or so millibars. And then let's put the PV on top of that. Different colors this time. Still, there's a protrusion. It's back. It's moved further below. This is the same elevation, this surface. It's gone further down into the upper troposphere or mid troposphere. And so one gets the impression there's more to come. But let's take a look at W. Nope. No more subsidence in the same location. This probably is the extent of this particular protrusion of PV along the sloping isotropes of this upper front. And in fact, the front looks weaker at this time than it did at the prior time. And so anyway, there is some development. We'll see much more robust upper front developments later on in the season. But this is an example of one. It's just not a particularly strong one. And let's go back to the top view here, Pete. Thanks. And here is the upper vortex piece that's unrelated to this upper front. It's more related to what's lying behind on this frontal zone itself. Remember, I've taken out some contours, but this is a fairly continuous swath of high vorticity tied to the jet flow that's along this baroclinic zone and has some vertical shear to it. This thing is going to marry that one, and let's see what happens. A couple of times forward. I don't want to steal Mike's thunder. But you can see something changing here, and that's going to be interesting. And this baroclinicity is intense by the time we get to midnight tonight. That's the upper front coming around the base of the trough and getting somewhat phased better with what was already there.
John,
Yeah.
you can go forward for the East Coast because I wasn't going to focus on that.
Oh, okay. Well, on the fly then, can we try and draw a cross section through this, Pete, along that line of theta and PV and W? That's pretty darn good. We'll just say that's great. Now, my expectation is by the time this vortex structure gets around the base of the trough, no longer going to have subsidence associated with it. There's going to be assets. So our yellow cross section may have almost nothing on it. So let's take that off for the time being anyway. Let's see what theta looks like. Yeah, that's a nice upper front, but it's starting to have a sense that it's getting deeper and deeper to the ground. This isotrope here is not part of the upper front. It's part of the mound of cold air. Here's the upper front baroclinicity that still doesn't get right to the ground, but it's more impressive looking than it was. Let's take a look at PV on this.
John, the connection or lack of connection with the ground, What do you make of the significance of that?
I'm just saying it in the sense of there's a differentiation between the upper frontal portion of the barytonicity and what was left behind in the lower troposphere. So there's not a single isotrope within this bundle that gets to the ground. And that's it, just that there's a distinctive, origin for these two different parts of the baryclinic structure that's deep. I bet if we put frontogenesis on top of this, the whole thing has some frontogenetic activity associated with it. And you can see that the PV has begun to retreat. Again, same level as all the times. The PV has begun to retreat, suggestive of no longer any downward vertical motion, but maybe upward. Let's see what that says. Oh, there's strong downward vertical motion on the cold side of the front. It's probably frontogenetic on that. I'll bet you if we change this to go from 0.2 or 0.02, not with a minus sign, they'll be, yeah, all the way to 100 or something. Probably need a comma there too.
I think there's a comma.
Oh, that looks like a period.
It goes to 10, but.
Okay, and that's the upward vertical motion. So here's the plume of upward vertical motion associated with this frontal structure. I didn't change the color, but that's upward vertical motion. Look at this, it's really intense in the upper troposphere, right near the jet. I think that must be warm advection through the jet core or something. And then this is a response perhaps to the modest frontogenetic activity that's characterizing this front. And then the downward vertical motion we saw on the cold side is part of that circulation as well, but stronger on that side for some reason. Interesting, worthy of more investigation. So plume of intense vertical motion embedded within a broad region of vertical motion. If we go to the top view, and that's all out here in western North Carolina. So if we could put sea level pressure on, we can see what's happening to sea level pressure, MSLP. And let's make it blue maybe. I don't care what color blue as long as it can be seen. Maybe we need to put a little bit of something. Yeah, that's something to make it a little bit. That's perfect. Yeah, that's good. And let's make it every 4. And this by me defaults to 7 millibars, which is just a ridiculous decision.
The maximum minus the minimum divided by however many contours.
Oh, okay. But it's always 7. That's weird. Okay, so here's the sea level pressure minimum. Remember, our maximum vertical motion is on the southern end of this, tied perhaps to this baryclinic zone. Let's march ahead a couple of times. Okay, here's another time. If you use the isotherms at 500 millibars as a proxy for the thermal wind, it's not perfect, but it's reasonable. And that's going to be pretty strong over eastern Pennsylvania and eastern New York State. Put the vorticity back on. The strongest PVA by the thermal wind is just to the northwest of the present position of the surface cycle. And that's commonly the case. And then a lot of this strong baryclinicity and strong vorticity is not really strongly affected because of the orientation of the isoplats. But it's pretty strong right up here over sort of the Tug Hill Plateau region of New York State. Let's watch again another time. Oh man, now things are getting aligned better. Look at how the sea level pressure minimum over northern Maine. Caribou, goodbye Caribou. Strong thermal wind implied by the thick of the isotherms, and then a bulbous head of PVA by the thermal wind right about coincident with the cyclone, and that's when it takes off. So you could keep on going if you wanted, but you'll see what happens. Boom. Explosive cyclogenesis over the Maritimes. And that thing, it struggled for 3 days to turn into anything, and suddenly it does. So it's like the ugly duckling. But there it is. But nicely diagnosed by all of the most basic things. So, and an origin with a weak upper front. There'll be better ones. So thank you very much, Pete, for driving through that. You're expert at this idea. So, and that's all I have.
Thanks, John, for exceptionally clear discussion of upper front. I think it's good. And I'm going to look at it from a slightly different perspective, but not the East Coast of it. So what we're starting off with now is another way to view the same Vis5G structure that Professor Martin was just showing us, which is the look at the dynamical tropopause. In this case, it's a potential vorticity surface that is fixed PV surface, 2 PVU surface. We'll get the pressure on it. So the cooler the values that you see on here, the lower the dynamic tropopause is. And as Professor Martin was just saying, we were looking at those cross sections. For this particular feature, it was extending to below 500 millibars in terms of the pressure on that surface. So you can see that really clear, distinct upper trough. The position of it's actually a little bit further to the east than it was in the forecast, I think, from the earlier forecast you're looking at. But this is the same depiction of that structure. This is locally lower here, higher in other regions, and a nice broad, warm region on the dynamical tropopause, which is just indicates that there's a slope here. So you can actually ascertain where the fronts are, the upper fronts are, either in that cross section, full view, or you can just look at the pressure here. The very rapid change in pressure along the dynamical tropopause is also a nice indication of where there's a strong slope to that. And you could also map this out with potential temperature. You'd also see the strong edge of that upper front shows up really nicely here, where you go from purple all the way to this light blue really quickly. You go from light blue to yellow from a gradual region. That's just a very elongated region of a weaker, much weaker front, or just a gently sloping tropopause. But the feature that I want to look at the most in this next series of maps is this feature that's located over the Pacific Northwest. We saw it in the satellite imagery. This is just about to make, it already crashed into the northwestern Pacific Northwest coast. And this is another region of depressed tropopause. You can see a slight hint of cyclonic curvature to it. Downstream of it, you can see sort of an enhanced ridge along the dynamic tropopause, and then the straight northerly flow. And so we saw, I made the comment at 500 millibars, we don't see significant flow yet across the Rocky Mountains. It's generally almost parallel to it or slightly just across it. Watch as this westerly flow, we're going to begin advancing these maps forward at a time. This, with the westerly flow, the zonal flow begins to move toward lower latitudes as it begins to cross the Rocky Mountains. It begins to descend. It carries with it a whole bundle of isotopes, warmer air in this adiabatic descent on the east side of the Rocky Mountains. That creates what we'll see is going to be a thermal ridge near the surface. We bring this upper trough interacting with the thermal ridge. We begin to see cyclogenesis occurring in the southeastern part of the United States. So let's first just advance this series of maps slowly in time. These are every 6 hours. You see the upper trough as it begins to dig further to the south. You can see the westerly flow at the dynamical tropopause. These winds are in the upper troposphere. But even in the lower troposphere, you're getting a westerly flow across the mountains. We're going to expect to see, we'll look at this in the 850 millibar map, to see warmth occurring just to the east of the Rocky Mountains. And we have this very potent upper trough that comes down. A little bit further, you can see this upper trough begins to amplify. It doesn't look anywhere nearly as impressive as the trough that was amplifying the storm over New England that Professor Martin was just talking about. But we do get this cyclogenesis event. Sea level pressure down to 1,005 hectopascals at this point. And you can see some modest deepening. Doesn't keep the sea level pressure indicator under the minimum all the time. But we can watch this trough as it begins to approach us. Remember, often east of these troughs, downstream of them, is where we're going to expect to see some inclement weather. And that's, we're now looking at 6Z on Sunday. So this is now going to be midnight on Sunday. No, it's still going to be 1 a.m. before we switch our clocks back this weekend. But this is going to be a rainy event. Okay, and we'll see this at the over. So I just want to carry through this, just a few more clicks on this, just to see the evolution of that. So that's going to be an event that goes by us and gives us significant precipitation. And yet, we talked about this long extended jet. Here comes yet another one. Yeah. Something really bizarre is going on in their analysis right here, but almost like a dragon, right? It's on fire-breathing dragon. But anyway, very deep trough that occurs, and we get yet another strong cyclogenesis event. This is going to be the event that's going to dampen people's spirits somewhat as they go out to joyfully vote as this upper trough approaches the Midwest again. So unfortunately, another rain event on Tuesday, but again, that shouldn't stop people from getting out and exercising their ranges. So please do that. And I think we have one more event in this sequence along with the tropopause.
What an active period.
Yeah, this is one of the most active periods we've seen since, I guess, last winter.
Yeah.
And then after this, we get really cold. So let's actually go to the surface map and let's go to pivotal, please. Just set up a little bit. And we'll look at the surface and we'll look at some of the features that are contributing to that. So models. And we'll start at 6 hours. And we'll look at the precipitation. So with each of these features in the upper troposphere, we also can see some evidence for on the other surface. Here's that area of light precipitation, that's accumulated precipitation that was expected that we saw on the radar. There was light precipitation here. You can see the thickness trough that's also associated with that upper wave that we're looking at along the dynamic tropopause. And the last vestiges initially of the rainfall along the east coast of the United States. But again, the focus is going to be on watching the evolution of this weather system in the Pacific Northwest. as it develops down here over northern Texas and then advances toward the northeast. So just because of time running a little bit short, let's go to 18 hours out. So go ahead, 12 hours. 18 hours of the forecast. You can see we're beginning to create a ridge in the thickness pattern. Those of you in 310, we've been talking about thickness. The average temperature, in this case, this is between 1,000 and 500 hectopascals, so it's proportional to that. That flow, the westerly flow over the Rocky Mountains, which end about right here, foothills, and then it sinks. This is this warming that gets created as the westerly flow pinches upon those mountains and then subsides. So we're getting this thermal trough. Now, why this is important, if we go to 850 millibars at this time, we're also going to see the emergence of temperature 2, 3. Okay, a trough in the pressure in the height field just east of the Rocky Mountains. So this trough is going to be associated. We'll learn later on. Look at these features. This also is going to be associated with some cyclonic geothermal vorticity in the lower troposphere. When you think about cyclogenesis, there are often sort of two ingredients that occur with it. One is a lower tropospheric vorticity anomaly. It might be manifest as a thickness anomaly or a temperature anomaly, positive temperature anomaly, and a very vigorous upper trough. And we have our upper trough that's formed with a westerly flow just to the east of the Rocky Mountains. And next we have this upper trough, which is not shown on this map, that's going to interact with it to produce our vigorous cyclone. We'll note that on late tonight, we're going to have temperatures over us at 850 millibars, which are certainly cold enough to support frozen precipitation. These scroll up just a little bit. Okay, so the zero line is well down here, so we're definitely cold enough. And so the question is, once we get precipitation developing, what's going to be the type of it, but it's going to be a ways before it starts. So we'll have another 12 hours to 30 hours tomorrow afternoon. Okay, that thickness ridge has begun to dissipate somewhat, but we do have a cyclone that's formed in the central plains. Okay, and we can also see the significant warm advection to its east, cold advection to its west. So we're getting transports of heat with this cyclone, which is going to be help it to energy to begin to develop. But here's our sprawling cyclone that's located. It's moved from the central plains northward into the eastern, just almost over Lincoln, Nebraska.
Nice, that'd be a difficult frontal analysis to try and make. I think all the fronts would be up to the north. There's nothing down to the south, right?
Yeah, so you have, where do you go from? One from might be all the way in here, but there could be a second. I mean, there's a front, and then there's warm air.
Yeah, right. It's just weird. And then
this is going to be right. Yeah, so I guess the warm front.
And then the pressure trough through Kansas and Oklahoma is not a cold front. There's no colder air in the west. It's actually warmer.
Yeah, so this would be where if you're going to put a cold front anywhere, it might be
right. That's what I think.
All to the west of here, a trough, and then a front that's perhaps well to the north of that.
Yeah.
It's a really weird structure. Okay, let's go ahead to 42 hours, please. The 850 millibars, we're seeing a really much more well-developed, more classical-looking type of disturbance. It's been largely stationary over this time, slowly drifting over that 12-hour period to the east as it begins to consolidate. Nice, strong cold advection to its southwest. We're in a region of fairly brisk warm advection. And I guess if you're going to try to analyze a warm front, this might be something to all the way up to here in this deformation zone.
Yeah.
You see a nice fluid flow. So you might expect some significant precipitation. We'll look at the amounts starting at 0, 0 on the 6th are going to be located well to the north of us during this time period. We're now clearly warm enough for this to be all liquid precipitation. Well, let's just go back to 36 hours. Let's go back 6 hours back. With 6 hours back, we're still at 850 millibars. It would be cold enough for frozen precipitation. Strong warm advection at this point. Cyclone center at this point is located actually in a thickness or a temperature trough at this moment. And you're looking at evidence for any sort of perhaps frontogenesis. That band is right, just maybe over us or slightly to the north.
Are you saying we might stop a snowflake?
I'm not saying, I'm just saying.
Oh, okay.
There'll be precipitation, it'll be cold. If it, depending on the arrival time of it, how dry we are at the surface, a number of factors, we could see a few flakes.
So you're not going to say it's going to snow, but you're going to say people who like snow are saying it's going to snow.
Right. I think they have provisions, although I just did. So we're going to have, this is, the precipitation is going to basically shift northward as this warm front or developing front, the region of frontogenesis also shifts northward. We'll place it about here. I think at 0 on Sunday nights at 7 p.m. We go ahead 6 hours again back to 42 hours. I think that zone, that's kind of
That
silly.
always happens, I know.
It's shifted to the north, and so that's where the heavier precipitation is going to be. And then we're basically the warm sector that's really nicely developing the cyclone. We'll go ahead to 60 hours. Well ahead. And this cyclone continues to progress slowly to the north, clear the warm sector, but now we're getting cold advection from the southwest.
Southwesterly winds.
Southwesterly winds, cold air coming. So let's go back to that surface map and look at the same evolution. We'll start at 18 hours in the forecast. Again, here's where this, not quite down at the panhandle, but we can see here near the northern edge of this warm thermal thickness ridge is where we have our cyclonic circulation. The upper trough's about to interact with it. We'll go ahead 30 hours. 2004. We're still not no significant development just yet. It actually does seem to shift further to the south. They're pushed away from the mountains. The interactions, we have a cyclone center that's located in central South Dakota.
This looks like the initial time for November 9th, 10th, 1998. It's incredibly similar. Yeah.
Nice upper front that evolves into a nice upper trough. So there we are. And let's watch as this sort of begins to fully itself together. We'll go to 42 hours. Okay, this is when we're thinking about the precip will likely be more in the form of the heaviest accumulated precipitation to start after this time period. Let's go back to 36 hours. Sorry, Pete. This is accumulated rainfall. So the precipitation has not started over us yet by 0Z. No. And we're cold enough, if it were precipitating, for it to be perhaps frozen. The cyclone center is this elongated region that's located along the Kansas border, right over Kansas City perhaps. And it's down to 1,008, maybe 1,007 or so for the center. And then we'll go ahead again back to that 42-hour time period. Again, remember these maps don't show the instantaneous precip rate, just how much is accumulated. There is that precip with initial slug of warm advection and the frontogenesis that's already occurred. On the very northern edge of it, you can see here, the diagnosed precipitation type is going to be snow. So
That's north of it actually is precipitation rate, not accumulation.
I think it's actually, I think the way it's labeled, but I think they take the difference between the two time periods, I think. I don't think that's a modeled output variable directly in this. So this is how much occurred over the last 3 hours and at this time. We go ahead another click. 2008, 2006, 2005 perhaps.
48 or 60.
Let's go to 48. So 2005 perhaps, and now we're down to 2006, 3 more millibars in that. So really wound up a very slow moving storm. Clear cold front finally beginning to emerge from the system. And the warm front I think is well to the north of this. It's not really going to be well defined. Really nice cyclonic circulation.
Yeah,
and heavy and modest precipitation to the south. Let's go ahead to 60 hours, please. At 60 hours, it begins to fill, and we're left with sort of more, this is accumulated precipitation this time. There's sort of showery precip left over us at this point. But really, doesn't get as deep, anywhere nearly as deep as the east coast of it.
Yeah.
But a nice development that comes from what looks to be a fairly modest upper wave. Let's look at the total accumulated precipitation through this time period. And you see the heaviest is well over west, but we're looking at probably just about 7/10 of an inch perhaps. But we're actually moving the cursor over us.
Yeah.
And further to the north, and over to the west, 1.66. Okay, so a rainy weekend coming up. It's going to start late tomorrow night, probably after sunset. And then last for much of the day on Sunday, I think we're still getting light precipitation, just ending by Sunday afternoon, Sunday evening. And this is now 6 p.m. on Sunday. All right, and let's go ahead to 84 hours. We'll go to Monday or end of Monday. This is that next cyclone that's expected to develop. Here's the old one, it's filled. Here's the next one that's coming by. Lots of heavy precipitation with it. This is Tuesday night. Get up early to vote, which everyone generally does, right? So we go to 96 hours.
Oh, yeah.
6 a.m. It'll be stormy, it's going to be windy, but those winds are going to be blowing change.
That's right.
In a lot of places. Unfortunately, I should say, fortunately, I would say that in, in states that have interesting dynamics going on in a political sense, hopefully this rainfall doesn't depress turnout. And then we can go ahead to 120 hours. This winds up. A nice, strong cold advection on advancing over much of the northern tier of the United States. And I think we're done, but let's just go a little bit further. We'll go to 144 hours.
It's a really major development, that storm is.
Yeah, that second one really gets down to 976, if not lower than that. And then we have snow well to our south. Wow. Possibility of that at least. We go 168 hours. Watch this, John. You probably want to go back, 156. But we saw this last week, right? We saw the region.
Look at that, snowstorm for St. Louis in November.
Yeah, this is going to be. And we can do the trick of going back to an earlier model one just to see how this, look at those years we run, for example. 60.
Wow.
We do 60 same time.
Wow.
So this is different. And we go to a different model. Let's go to GDPFS, the Canadian model. Valid this time.
They have the same structure.
Same structure, but the cold advection is just overwhelming this. So but these are wintertime thicknesses.
Yeah, they sure are.
So we'll go back to the GFS just to be consistent with what we've been looking at. And we'll see that this misses us. This area of snow goes into Michigan. And I'm going a week out, and we know that's really cold. And if you go look at surface temperatures for next week, if this verifies,
28.
This is in the morning, probably in the teens perhaps.
Wow.
Wind chills much colder than that. I think
You're not getting above freezing during the day.
Wind chills like 8 degrees Fahrenheit.
Wow.
So bundle up. And maybe we can just let this go back to the surface mass and look at the rest of the outlook. But we go through a cold period, but then things begin to warm up. Everything, that jet in the Pacific seems to relax a little bit, and then we get some warm. East Coast snow maybe all the way out in the Carolinas. It stays cold. These earlier forecasts did warm us up. This looks like we're going to turn off the sun now. All right.
That's really cold. Persistent 522 thicknesses.
And here comes the warm advection, well to our north.
More snow. Central Texas. More in St. Louis.
Did Texas get snow in Mexico before we did last year?
Probably.
So here's our,
Without even looking it up, I'll just agree.
another one of these sort of phasing events with a cyclone off the east coast of approaching.
So-called secondary.
They've been quite phased, but we've been beginning to moderate again, but that's good. Anyway, so in short, for the weekend here, tomorrow's probably going to be chilly but dry most of the day, and then we actually warm up. Not warm up, we get precipitation tomorrow evening into Sunday. Most of the day Sunday should be wet. Got a break on Monday and then more rain on Tuesday. Again, done with that. Pretty. All right, well, thank you. Thank you, Pete, for leading us through this, and also thank you, John, for a really great discussion of the upper final. Thank you, Pete. Let's see you.
Wear your gloves next week. It's going to be cold. Really?